previous lesson we learned how to write the equation of a line given a point and a parallel line. So today what we want to look at is how to find an equation if we're given a point and a perpendicular line. So let's say they asked us to write the equation of a line passing through 1, 5 and perpendicular to y equals negative 1/2 x plus 5. Now the key here is to remember what perpendicular means. Perpendicular means you have an opposite reciprocal slope. Opposite meaning the opposite sign, so if it's negative it becomes positive or positive becomes negative. And reciprocal meaning if it's a fraction, well, whether or not it's a fraction you have to flip it. So right now we have a slope of negative 1/2. Now we're told it's perpendicular to the negative 1/2. So we take that fraction and we flip it over. We make it 2/1. And because it's opposite, we change it from being a negative to a positive. So our new slope is 2. So perpendicular, you just take the slope, you flip it, and change the sign. So we use y minus y1 equals m times x minus x1. We get y minus 5 equals 2 times x minus 1. We can then distribute the 2 and add the 5 to both sides. Now we have another example. Write the equation of a line passing through negative 2, negative 3 that is perpendicular to x plus 4y minus 8 equals 0. Again, it's important to remember whenever you're asked to write the equation of a line that you need a point and you need a slope. The point here is given, negative 2, negative 3, and the slope we're going to have to find. Now we know it's perpendicular to this line, x plus 4y minus 8, but it's not easily seen what the slope of this line is. So let's go ahead and figure that out. We do that by putting it in slope-intercept form, or in other words, we solve for y. So I'm going to start by adding 8 to both sides, then subtracting x from both sides, and then dividing everything by 4. Okay, so notice I divided every single piece by 4. I did 4y over 4, negative x over 4, and 8 over 4. So the slope of this line is negative 1/4. So a slope of a line perpendicular to that, you would flip the fraction and change the sign. So since it was negative, we make it positive. So our slope is 4. So then we can do y plus 3, because it's minus a negative 3. Then our slope is 4, and then x minus negative 2, that's plus 2. We distribute the 4 and subtract 3 from both sides. The next thing we need to cover as far as linear things are concerned is linear modeling. Modeling means we're going to use math to try to describe something in the real world. So linear modeling means we're going to try to use lines to describe some things that happen in the real world. So there's two main things we need to focus on here, and that's again the slope and the y-intercept. So let's think about just a general equation here. M is our slope and B is our y-intercept. And one thing you're going to be asked to do is interpret what those things mean in terms of the problem. Okay, so now this is going to seem really general right now, but once we do some examples I think it'll be a little more clear. So first thing, B is our y-intercept. And it represents how many y's we have when x equals 0. Now that may seem really weird, but let's see, if you want to think of an example, let's say we're looking at the change in the population of a country over time. Usually we might start time 0 at like 1950 or 1990. We usually don't start time 0 at the beginning of time because we don't have data back that far. So let's say that 1990 is time 0, and we model the population of North Carolina. I know that's not a country, but we'll just change it to that. North Carolina over a period of 1990 to 2010. So that's what we would be modeling. Well, if we treat 1990 as time 0, then what that B will tell us, what the Y-intercept tells us, is the population in that initial year in 1990. So that's what that means, and again, you'll see it more as we do a couple examples. Alright, the other thing we need to be able to interpret is M, which is our slope. And that's how quickly or how much Y changes per change in X. So for example, if we were to model the population of North Carolina from 1990 to 2010, then we would basically be figuring out how much the slope would be, interpreting how much it changes per year. So Y would be our population, X would be our year. So the slope would tell us how much the population changes per year. So it's important to realize that B, Y-intercept, that is a set amount at a certain time, or a certain value of X. M, the slope, is a rate of change. It's how much something changes over a set period of time, or over a set in relationship to some set amount of X. Here's one example. Let's say 14 million women lived alone in the US in 1995. In 2010, that number was up to 17 million women that lived alone. So what was the rate of change in women living alone per year? So what this is really asking us is to find a slope, because a slope is a rate of change. It's how quickly one thing changes in relationship to another. So we're asking, how much did the number of women who lived alone change per given year? So you treat this just like it's 2 points and you do the slope formula. Time is always going to be an X value if you have it. You won't always necessarily have time, you often will, but time will be your X value. So our first data point would be 1995, and that was when 14 million lived alone. And our second data point would be 2010, and that would be when 17 million women lived alone. So that gives us our slope, our 2 points with which we can find our slope. So I'll do 17 minus 14 over 2010 minus 1995. That gives me 3 over 15, which is 1 over 5. So 1 over 5, or 0.2. Now remember, this was 14 million and 17 million. So if I was asked to interpret what this slope means, I would say 0.2 million more. I know it's more because it's positive. If we got a negative, that would imply that we are decreasing or going down. 0.2 million more women live alone in the U.S. each year. So see, the number of women we have is our Y value. So that's how many more women lived alone in the U.S. each year. And each year represents our X value, because our X value is time for this. So that's how the number of women living alone changed per year. So it's the number of Y's change per X. Here's another example of some things we can do with these linear equations. It says the population of the U.S. in 1960 was 179.3 million. In 1990, it was 250 million. Use this information to predict the U.S. population in 2010. The way we do this is by creating a line. So if you notice, we have 2 data points. 1960 we had 179.3 million. In 1990 we had 250 million. Now one thing we'll typically do with years is treat the beginning year as times 0. So in other words, instead of doing 1960, I'm going to call that times 0, because that's where we're starting from. That's our starting point. That'll make our equation a lot nicer. So at times 0, which is 1960, we had 179.3 million. And in 1990, which is 30 years later, we had 250 million. So remember, when you're writing the equation of a line, you need two things. You need a point and you need a slope. We have 2 points right here, so we have a point. We need to use these 2 points to find our slope. So we would do 250 minus 179.3 over 30 minus 0. Okay, when you plug all that in, you should get a slope of about 2.356. We'll generally go to 3 decimal places. So 2.356. So that's our slope. And remember, what that implies is that the population of the U.S. increases by 2.356 million people each year. Okay, so now we can write the equation of the line. I'm going to use the first point. Remember, you can use either one, but since it has a 0, I feel like it's going to be easier, so I'm going to do that. So y minus 179.3 equals 2.356 times x minus 0. So now I distribute the 2.356 and add the 179.3. Okay, so this is the equation that I'm going to use to model the U.S. population. I have two things again. I have my slope and I have my y-intercept. My slope tells me how much the thing is changing. It tells me that you're changing at a rate of 2.356 million people per year. And the y-intercept, 179.3, tells me the amount of people I had in 1960, because that's my time 0. That's where I'm starting. So the y-intercept is a set value at a set time, 179.3. The slope is a rate of change. But we haven't answered their question yet. It says use this information to predict the U.S. population in 2010. Alright, so you have to think carefully here. Our x value, sorry about that, our x value is the number of years after 1960. Remember, for 1990 we put in 30. So if we're looking for the population in 2010, that would mean 50, because that's 50 years after 1960. Now my x is time, and my y is population. X is time and y is population. In fact, if you wanted to put p equals 2.356t plus 179.3, you certainly could. Okay, so they want us to predict the population, so we're trying to find a y value. We're trying to find the y value when the time is 2010, and that's 50 years after 1960. So I'm going to plug 50 in for x, because that represents 2010, and then solve it. I can do this in the calculator. 2.356 times 50 plus 179.3. And it's estimated it'll be 297.1. So we estimate that in the year 2010, there will be 297.1 million people in the U.S. So this is the kind of thing we need to do. We need to know how to find the slope, what it means, how to find the y-intercept, what it means, and then be able to use those equations to predict what will happen in the future.